In this part of the video, I will again try finding out the coefficient of static friction between the green surface and the wooden surface with both inclined plane and a pulley system. But there is a change in this, as I have already set an angle which is lower than the angle of repose so that the body does not immediately slide down. So for this situation, I have taken the angle to be approximately 30 degrees. And right now, let me just analyze the whole forces acting on the body. So here's the given theta, and for the earlier part, we know that if this is theta, that means this is theta. And since there's a vertical component and a horizontal component for m1g, since theta is in contact with this component, that means that this will be m1g cos theta and the horizontal one will be m1g sin theta. And normal reaction, which is n, is always acting perpendicular to the plane of contact. So normal reaction is acting in this direction. And for this plate mass, the weight of it will be acting in downwards direction, which is m2g. And since there is a string connecting both this mass and this plate mass along with these pebbles, the tension force will act in this direction for this block and in upwards direction for this plate containing pebbles. And since as we are going to add more and more pebbles to this plate, it means that the tension force will slowly increase and it will also try pulling this block upwards. And since friction wants to oppose the relative motion of the body, it means that the friction force will act in this direction for the body. And since I always want to calculate the coefficient of static friction of a body at a specific condition of just moving it, it means that actually Fs max or maximum static friction force will act on the body. But before all that, as we can see, there is no vertical movement on the plane of the inclined plane. So at first we will write that n is equal to m1g cos theta. And for this plate mass with the pebbles, the equation will be T is equal to m2g. As the body will be just moving, it means that this will be in equilibrium, so T must be equal to m2g only. And for tension of this particular place, it will be equals to m1g sin theta plus Fs max or maximum static friction force. And Fs max already we know is mu s into n. By replacing mu n's value over here, we find it to be mu s into m1g cos theta. Now we will put all the values to this equation. So we get it as m2g is equal to m1g sin theta plus, for Fs max it is mu s into m1g cos theta. All the g will get striked off, and in the end we get that the value of mu s is m2 minus m1 sin theta, and the whole is divided by m1 cos theta, as you can see over here. So we have find out the equation what is the value of mu s. So right now let's do a real life example of it. Right now we just slowly add all of this. As you can see, the body has still not started moving. It has still not started moving. Now let me see if it starts moving or not. As you can see, it has just started moving. So right now I will just measure the force of this like plate with the pebbles on. Let me just turn this on. So it is approximately equal. It is like approximately equal to 110 grams or like that. So for M2, the value is 0.11 kg, and we have already measured this block. It is 100 grams. So M1 is equal to 0.1 kg, and the theta over here is equal to 30 degree. Now by putting all the values in the given equation, we find out that mu s is equal to m2, which is equal to 0.11 minus m1, which is 0.1 kg, into sine 30, which is half, divided by m1, which is 0.1 kg, into cos 30, which is root 3 by 2. And if we calculate like this whole equation, finally we get the approximate value of mu to be 0.7. So this value is like again same from the earlier experiment we got, and also from the earlier experiment we got. So it means that this confirms that the coefficient of static friction between this green surface and this block is 0.7, and we have actually find out the approximate value by doing 3 different experiments. And we can also like find out the coefficient of friction between the 2 wooden surfaces by using these 3 same experiments also. So I hope you like this video. So for now,